And we're live now. Go ahead, Lorna.
Hello, everyone. Welcome to the last keynote of useR 2020. We would like to thank RStudio so much for sponsoring useR 2020. And for our last keynote, we have Shamek, who works as an associate professor at Oslo University of Technology. He teaches R, data visualization, and interpretable machine learning. In 2002, he graduated in mathematics and statistics and software engineering. And in that same year, he fell in love with R. His first time to attend a useR was in 2008. And in that same year, he was able to publish his first library on CRAN. So after 12 years, he's still working on this library, and he's a big believer in data literacy. And he's working on another project called Beta and Beat, which is essentially a series of stories and data-oriented games where siblings Beta and Beat are interested in math and computer science, and they're using these skills to solve real-world problems. You can check that out, Beta and Beat, on CRAN. Today, he's here to tell us all about talking to our models. Welcome, Shamek.
Thank you for the introduction. Let me start. Okay. So, hello, my name is Przemysław Wiecek. I'm R user since 2002. Today, I would like to tell you why you should talk with your predictive model and also how you can do this. So basically, for years, I have been working on predictive models with application to medicine or biology. And I was convinced that we are training good models and actually we are doing good science and we are supporting clinicians and biologists. But think about, a similar approach that is presenting in some newspapers like this one. You can read in some articles that machine learning actually is creating science, creating crisis in science. So, it's kind of devastating, but we see examples that support this more critical view on machine learning. For example, even large companies like Amazon fails when they are training model because of some historical bias, and because of this historical bias, a model that was trained on the data was become sexist. Or problem with Google Flu. After a few years, Google Flu was working pretty nicely, but after a few years, the performance deteriorates, and now it's not available anymore because it will be worse than benchmark. And there are other examples of problems like that. For example, IBM Watson also get a pretty bad reception, and in some articles, it's claimed that the recommendations are unsafe or inaccurate. So. Even large companies with lots of talents and resources, access to a huge amount of data, even they have problems with machine learning models. What about smaller companies? Yeah, it's even more likely that we experience some problems. So, where do these problems come from? I think that many of these problems come from the fact that predictive models are not really well tested. As a software engineer, I think that in software engineering, the testing is pretty important part of our job. In case of machine learning models, it's not the case, in my opinion, and I will try to convince you why. So currently, it's very easy to get from the I have data to I have model. We have excellent frameworks, and you can train your predictive models with just few lines of code. But then after some time, it turns out that despite high F1 score, accuracy, anything, after some time, the model performance deteriorates and there are some problems. Our model is not working as we expect. So what we can do? How we can create better models? In this talk, I will try to convince you that by talking with the models, you can do a very good diagnostic discussions. And then these discussions will help you to build better models. And you need to put a lot of care to test your models because otherwise they will stop working after some time. Okay, so the area of, let's say, model testing have many names. Probably the two most known is explainable artificial intelligence or interpretable machine learning. And you can use methods that are covered by these titles to explore your models. Although personally I prefer a different name. I think that these two words like explainable or interpretable, they start very often philosophical discussions like what does it mean to understand and what does it mean to explain to a non-technical user. So the name that I'm going to use is more pragmatic. I'm going to use the title explanatory model analysis to highlight that our goal is to analyze a model, uh, to explore the model, explain how it's working, to have a better look on the model. And this exploration will help us to do the more in-depth diagnostic conversation of the model. So usually when I present these techniques, I do it in a book-like manner, showing a technique after technique. But today we have a user conference, so I would like to do this differently. I would like to show you these techniques, how they are related with the other talks that were presented in recent years at other users. So this is my 12th user conference. And over the years, I learned a lot about modeling. I've heard a lot of very good talks about from practitioners, from theoreticians, from dreamers, from pragmatists. So it turns out that a lot of explanatory model analysis topics have been introduced in these lectures years ago. So I will try to link these topics, these methods with talks that I've heard in the past. I hope that this will be an interesting journey for you as well. So since I'm supposed to talk about models, let me first define what the word model means for me. Because if you work with biologists or clinicians, you know that the word model has very different meanings for different people. And you can think about a specific instance of a model, like trained neural network, a single instance of the neural network, or you can think about some implementation of some generic algorithm, like implementation in Ranger library of random forest model, or you can think about, in general, about some algorithm. You can think about set of equations, like in Lotka-Volterra models, or you can think about small car. I'm always surprised what the word model means for my colleagues in other disciplines. So to be more concrete, for me, the model is a p-dimensional function that takes a vector of p features and returns a single number, calculates some model prediction. So it's kind of maybe more simplistic approach. The model is a function trained by specific algorithm on specific data set. And exploration of a model, by doing exploration, I would like to learn something about the function. So there are different approaches, and I will show some of them to you today. They have different names, like you can be interested in the difference between the model prediction for a particular point and the average model response. So there are excellent techniques like SHAP to do this. You might be interested in some approximation, how to approximate model around point of interest. And there are excellent methods to do this, like LIME, for example. There are some methods to trace the model response along some covariate. And there are methods like ceteris paribus, and also I will try to show you an example of such models. But overall, the idea is to understand the function, which is pretty complex because it's in the p-dimensional space, but understand the function through some low-dimensional summaries, so-called. So to make this presentation more concrete, I'm going to show you two use cases on two predictive models. And the first one will be related to the prediction of probability of hospitalization among people infected with COVID. So I will show you results obtained on real data set, but please know that this is just an illustration. I would like to show you some approach to modeling. I will not claim any diagnostic value of the model. I am using this example because most of us heard something about COVID and we have some expectations. We have some domain knowledge. So it's much easier to talk with models when you can compare your domain knowledge, your expectations against things that model is telling you. So no, of course, no clinical results will be presented here, but since we have some expectations, it will be easier to cross-compare these expectations against results from the model. So let's start. In this slide, I've just trained a logistic regression model with splines with the use of RMS library, and there is LRM function which fits logistic regression with cubic splines. They are restricted. I'm using just two variables, age and comorbidities, and basically I'm calculating AUC and ARA under curve, AUC and ROC curve. So it turns out that ARA under curve is 0.75. Is it a lot or not? Hard to say. So in fact, recently I've done a literature survey for COVID-related predictive models, and you can find lots of papers, dozens of papers that introduce different predictive models for mortality, for severity, for length of hospitalization. In most cases, the model presentation is like that. We take data, we train few models, and we choose the best model out of these that were trained. This is so-called Kaggle-style modeling. Yeah, I would argue that we need to do more. And to do this, let me share with you a sentence from a beautiful presentation of Frank Harrell, which I heard in 2010 at USAR. The presentation, the title of presentation is Information Allergy. You will find a video by Frank Harrell at YouTube. So I strongly recommend you to watch this video. It's beautiful. And Frank Harrell said, optimum decision-making must use the most complete and current set of information that the decision maker is capable of handling. The most complete and current. So definitely single number like F1 or AUC, it's not the most complete set of information. For sure, we can do more. And let's see what we can do for this model. So let me start with decomposition of this single number AUC into parts that can be attributed to specific variables. So we can calculate feature importance to check how importance was featured in achieving this performance. So for example, we can use permutational feature importance to see how heavily the performance will degrade after the feature is perturbed or removed. And it looks like for this model, both features are pretty important. Maybe age is slightly more important. Okay, let's go deeper. Knowing that both features are important, we can ask, okay, so what is the relation between these features and the outcome, the target of the model? And here I'm working with a logistic regression model with splines, so I can actually use formulas which are estimated, coefficients of these formulas are estimated to draw these figures, but I am doing this in a model agnostic manner. So using techniques like partial dependence profile or accumulated local effects, you can do this analysis for any model. So basically what you can do, you can plot two panels, one for person with comorbidities, one without, second with comorbidities, and see what is the relation between age and the chances of being hospitalized. Once you have given, you got infected with coronavirus. And it looks like first, of course, if you have comorbidities, the chances are higher. So on average, this curve is higher. But second thing that you can learn from this curve is that there is some change in the relation after age 50. Up to years 50, the chances were pretty stable and relatively low, and then they're increasing pretty quickly. So you can talk with the model, you can do this exploration even further. You can look for, we started with single number, then we calculate importance of particular features. Then for selected features, we're doing this in-depth analysis of a profile, and you can go further to see what is happening with residuals, what is happening with interactions, if there are any interactions in the model, if variables are created, and so on. My point is that you can dig deeper and you can analyze model deeper to kind of contrast the model with your expectations. So to go further, I would like to convince you that analysis of a single model is not enough. And let me refer to a fantastic paper of Leo Breiman, The Two Cultures. If any of you haven't read the paper, I strongly encourage you to do so. Breiman describes two approaches to modeling. One focus on models that are explaining some real phenomena. So he told that 98% of statisticians are using this approach. And second is more algorithmic approach in which we are more interested in the performance, accuracy of model predictions. So the whole paper discusses these two approaches, these two cultures. They are using their own names for maybe same things like variable versus feature. So it's pretty interesting to see these differences. And my question today is, can we bridge these two approaches? Can we create a bridge? Can we learn from each other? Can we extract some information from these algorithms to understand the domain better? So let's see. The very interesting concept introduced in the Breiman article is the Rashomon effect. So Rashomon is an Akira Kurosawa movie about an event described by 4 witnesses, and each perspective is different. And in case of predictive models, Rashomon effect means that you may have a very different models that describe the same data in very different ways, find very different relations, but have very similar accuracy. And this is the example from Breiman paper, 3 different models, similar performance, very different descriptions. So to understand the model, maybe instead of to understand the data, maybe instead of having one model, maybe we need few models with this Rashomon effect presented by few models. So how this topic is linked with COVID hospitalization. Let me show you how we can cross-compare different models based on the COVID data that we have already learned about. So we have these 2 panels with a link between age and chances of hospitalization. And we have started with logistic regression model with linear tail restriction cubic splines. It's pretty elastic model. This is important. We have 5 nodes and cubic splines between them. So it's pretty elastic model. The performance, as we saw, it's around on test data, it's around 0.75. So now let me train another model and let me add this other model to the plot. So I've trained a gradient boosting model with monotonicity constraints. And I've added the model to these panels. And we see that actually both models, despite their different structures, because for elastic, for splines, we have very smooth relation. Everything, is very smooth. It's based on cubic splines. For gradient boosting, you have stepwise function, but both models on this data learn pretty similar relations. So we see that they are pretty similar. There are some small differences maybe on boundary, but they're pretty similar to each other. So okay, let's add another model. Now we can train a random forest model, for example, totally different structure. Instead of now we have a collection of trees. Each tree is trained on a subsample of data, bootstrap sample of data. And we see that the perspective of random forest model is slightly different. Again, the overall link is maybe similar, but we see that on the boundary, it's more flat. It's not that steep as in case of logistic regression with splines or gradient boostings. So there are some differences. And of course, knowing the internal structure of a model, knowing how random forest is working, we know that this is kind of regularization which is happening on these ends of interval in which we have just a few samples. But just comparing these 2 perspectives is interesting because now we can learn, okay, so which model is better, not only based on the accuracy or around the curve, but also based on some, the behavior of a model. Which of them is closer to our expectations? So let's go further. Let me add to this plot also a logistic regression, and it's pretty stiff model. The plain vanilla logistic regression is pretty stiff model. It is unable to grasp the heavily nonlinear relation. So we see that the model is more or less like this one. So maybe let's add one more model, classification tree. All these models are pretty similar in performance, more or less. There are some differences, but they're very small. And we see that these models learned very different relations. And now, by comparing these relations, we can discuss which model maybe is more likely to be selected or not. Let me add one more model to this plot. This will be the gradient boosting without any constraints. And despite very high performance on test data, the gradient boosting for this data learned is pretty unstable. The profile is pretty unstable. You see that there's huge variation. So personally, I would not recommend to use the model after seeing this variation. But my point is that it's good to see these models, and it's good to cross-compare these models, to use this Rashomon effect to compare different models, because then we can learn more how these models are similar and what is similar between them, what is different, why they are different, and then we can take better decisions. So I hope that you agree that it would be nice to compare models in a single plot, but it's not easy. There are some obstacles. And let me spend a minute by showing you what kind of obstacles we need to combat. Like for Ranger model, to extract model prediction, we need to use a predict function with additional argument probability equal to true, and we can extract the prediction slot and take a second column. But for classification tree, we need to set type argument to probe, and then the result of a predict function will be a matrix, and then we need to extract the second column. But for gradient boosting implemented in UXGBoost library, the interface is different. We need to set the type argument to response, and then the result of a predict function will be a vector. So you see that each algorithm has a different interface. And this is problematic. If you like to compare these different algorithms on a single model, then it would be nice to have a similar interface to each of them. What we can do? One approach would be to create a standard for model results. And we can assume that each trained model will work according to a new standard. But this might be not a very realistic approach, because there might be different standards, and this is a beautiful comic by XKCD. We have 14 competing standards, and after the discussion, we have 15 competing standards. So maybe there's a different way. Maybe there is a different way. And again, let me link this discussion to a beautiful presentation by John Chambers from user 2014, Interfaces, Efficiency and Big Data. And John Chambers told us about 3 key principles. I think that most of us know the first 2 very well, because they are frequently repeated. Everything that exists in R is an object. Everything that happens in R is a function call. R is built on many algorithms. Yeah, but the third one, maybe it's not so frequently repeated, but it's very important for this discussion. Like the thing that is embedded in our philosophy is that it's interface to many algorithms. And also what is maybe important on these slides by John Chambers is that the best feature is in variety, not uniformity. So how this translates to COVID, and how this translates to our discussion. Maybe instead of having new standard for training model, for new framework of training models, maybe you can adapt a philosophy of using adapters. Adapters, like you can train your model in anything you like, you can choose any library you like, but then you can use adapter, which will create some interface to your model. This model may be trained in Java with H2O. We heard yesterday a beautiful keynote about H2O. A model can be trained in Python with scikit-learn, or with in R with MLR, or with other tools. But having these models, now we can create an adapter, and this adapter will create a uniform interface to the model. Here we have interface created by the explain function of a Dalek package. I think that Dalek package has lots of functions, but the single most important feature is this adapter. So then having this uniform wrapper, now you can access models created in different languages. You can access them in new libraries, and you can do lots of things with these models, despite of their internal structure, because the structure will be kind of wrapped up in the Dalek in the adapter. And Francis Ascombe said that a computer should make both calculations and graphs, so we can uniformly calculate some statistics for these models, and also we can plot them in some uniform fashion. So maybe to show you an example, here you have these three models created with random forests, with classification tree, with gradient boosting, and then these models can be wrapped. These trained models, there are these functions, p-dimensional functions, they can be wrapped with the explain function. The function learns how to talk with these models. Sometimes maybe we should specify directly how this interface should look like, but once the adapter is created, then we can use this adapter in the same fashion in other functions, because we know that despite the internal structure of a model, we can access the model in a very uniform way. Okay, and this way it will be easy to use this Rashomon effect in practice, so to overlay different models in a single plot, because despite internal differences between these models, we can use these adapters to have some level of abstraction, and then we can kind of use anything that exists, any algorithm that exists in any language, and we can compare these algorithms in R. Okay, so let me now focus on the first part of title of my presentation, talk with. I already said what the model means for me, p-dimensional function, but let's now focus on this first part, language for interaction with a model. And of course, the name explanatory model analysis is a clear reference to John Tukey's famous book, Explanatory Data Analysis. I would like to convince you that the EDA is for data what the EMA is for models. And for the same reasons, we should use EMA for models. We should explore models, not only data, we should explore models. So in this slide, I put few quotes from John Tukey, which I found very relevant also for models, like numerical quantities focus on expected values, but graphical summaries on unexpected values. So if we're looking for something unexpected, plots are great way to work. Then if you are communicating your results to non-technical user, there is nothing better than clear visualization. Not only visualization of data, but also visualization of model. If you are going to communicate your model, then you should visualize your model. Yeah, make the point. And this well-known saying that the greatest value of a picture is when it forces you to notice what you have never expected to see. So let me maybe refer to this on a second use case. This time, I would like to aim on exploration, not on a whole general bond behavior, but I would like to focus on model behavior on a single instance, single observation. And rarely, single instance is interesting for us. In classical data sets like IRIS or German credit scoring, a single row, no, it's anonymous. It's not really relevant for us. We don't care. What does it mean? What is in the row 150? So I took data set which is maybe closer to our imagination and is closer to our expectations, and this will be a FIFA data set. You can download from the SOFIFA portal characteristics of many different players, like 15,000 of football players with very detailed characteristics. And then easily, with any framework you like, you can train a predictive model So in this case, I'm training a model that will explain or will predict the value of a player based on all other characteristics, 53 other characteristics. So now let me see how the model behaves for a single instance. And you can choose any footballer you like. I have selected Robert Lewandowski because he's the highest rated Polish footballer. He plays as a striker. And yeah, let's see how the model is working for Robert Lewandowski. So let's start this exploration with just a single number, as usual, a prediction. So the model prediction for Robert Lewandowski is 52 millions of euro. Based on all other characteristics, the model prediction is 52 millions of euro. We already know that it's not enough. A single number is not enough. Let's go deeper. So deeper means that now we can use different techniques like explanatory model analysis offers you many different techniques like Shapley values, breakdown, Lime, and this technique can be used to decompose the model prediction, these 52 millions, into parts that can be attributed to particular variables. So in this case, you see that there are variables like movement instructions, which is, for Lewandowski is equal to 90. And because of so high score of this variable, the final prediction of a model is increased by 2 million. So we can decompose all these different, we can decompose the prediction for these parts. As 2K said, plots help us to see things that are unexpected. And for me, what was unexpected is this negative effect of age. This is the only parameter, only characteristics that actually decrease the expected value of Robert Lewandowski by 4.5 million, so a lot. Yep. So why it's so? Again, we can go deeper in this analysis, and as for the whole model, now we can see a profile of response. So in case of Robert Lewandowski, we can plot a ceteris paribus profile. So assuming that all other variables are constant, what would be the model response if the age would be higher or lower? And we are getting this curve. And we see that because of age 30, actually the prediction is not so high. It will be even lower in 5 years. So you can dig deeper and deeper, look for interactions, do some deeper diagnostic and so on. My point here is that if you are working with a model, you should not stop yourself on a single numbers. It's not enough to report just accuracy, F1, anything like that, ROC. It's not enough to report a single prediction. We have tools, and you can use them to go deeper. For whole model, for single observation, you can look how to decompose this performance into parts that can be attributed to variables, how to decompose the prediction into parts that can be attributed to variables, what is the average response of a model in terms of profile for a single variable, two variables, or more variables, and you can go deeper doing diagnostic, and you can spend a lot of time to do this analysis, in-depth analysis of a model, despite the model structure. So it's not like you can do this only for linear models. You can do exactly each of these steps that I've shown. Each of these steps can be done in a model agnostic fashion for any model. And then also you can compare different models, which can be pretty useful. So I have still a few minutes, and I would like to convince you that for efficient communication, we need a quick feedback loop. And the quick feedback loop can be obtained with interactivity. And in our community, we have people that are working on interactive graphics. And here I have two keynotes. One was given by Hadley Wickham in AdUser 2017. And Dee Cook had two beautiful keynotes about interactive graphics. And they work on they have inspired a lot of interesting results towards interactive model exploration. So I would like to show you some of these ideas, how they translate to the exploratory model analysis. So let me start with this story about an elephant and a blind man. Maybe you know the graph. When a blind man experiences on a single aspect of elephant, like tail or something else, then he may be confused what in fact is being observed. Only by putting all these different perspectives together, only then we can really understand what is happening, what we are observing. So how this translates to machine learning models? Just think about model as an elephant. So you have this elephant black box model. Maybe it's not black box, maybe it's linear regression, doesn't matter. You have the model, and we also have tools, methods that can explain particular aspects of these models. And these are these first generation of explainers. So you can use Shapley values, you can use permutational variable importance, you can use ceteris paribus principle, you can use different things to see single aspect of a model. You can see the model from different perspectives. But to really understand how the model is working, we need this quick feedback loop, which allowed you to compare model from different perspectives to see at the same time how the model looks like from these different aspects. So it's not enough to have single methods that will explain some aspect of a model. You need something that will iterate over these aspects and help you to understand how the model is working. So let me show you an example. I have pre-recorded video just to be sure that everything will work. So this is a Model Studio dashboard created. This is the problem with live presentations. Let me try this again. Let me do this. Sorry for this. I will try to open this again, and maybe this time this will work. No luck. Okay. So I will try to show this example in a second, but basically Model Studio is a tool that allows you to see all these different perspectives at the same time. So you can, in one panel, you can see the composition of a model response for particular variables, and on different panels you can at the same time see what are the ceteris paribus responses. So on different panels at the same time you can compare all these different perspectives. So I will try again to show you this video after the end of my talk, but now maybe let's go further. It's time to maybe sum up topics that we have been talking about. Usually, when you think about building of a model, you think about some iterative process, like understanding data, then assembly of a model, and then should do some audit of a model. And you repeat these steps until you will get a good model, and then you can put the model to production. So I would convince you that you can use the explanatory model techniques to better understand each of these steps. So you can use them to better explore your data, as in case of Rashomon perspective for COVID models. We use 6 different models to see from 6 different perspectives what might be the relation between the probability of hospitalization and with particular variables. Then we can, in the interface model assembly, you can use these techniques as for the FIFA example to explain the model results. Like we saw this pricing of Robert Lewandowski. to explain which variables are the most important for this particular price, for this particular prediction for Lewandowski. And these effects might be different for different instances. They might be different for Ronaldo or might be different for other football players. And also we can use these techniques to debug model, to look for problems, to look for places in which the model behaves in a different way that we expect. So this way, maybe they are working against our domain knowledge, and maybe it's a problem, maybe it's something that can be corrected. So exploratory model analysis helps you to do these iterations and extract more and more knowledge from each step. So you can use them to do better exploration, better explanation, and better debugging of your model. So now let me share with you my belief about how the area of modeling is changing. So as a statistician, years ago, I built models for other domains like biology and medicine. And to do good models, we need to learn a lot about the domain. To have good transformations, to have useful models, we need to really understand the domain. So lots of time was spent on this first part. Exploratory data analysis, learning the domain, and then building a model was relatively easy. Relatively because it's still probably not that trivial, but once you understand the domain, more or less, if you are fluent in linear models, you can fit good linear model to the problem. And then the validation was relatively simple as well, because we can use just p-values or scores like RMSE to see if the model is working good or not. So in machine learning community, there is some shift of focus. The domain understanding is not so important for most people, and lots of attention is put in this part, like looking for different algorithms, looking for different models, optimize these models, how to find the best algorithm here. And also this last part, validation and justification, is also important because we have a lot of models, so we need to choose one of these models. And we need better techniques to compare these models. But the natural question is what will happen, how this might change over time. And in my opinion, this part will be also relatively easier and will be more automated. Right now we have excellent tools for automation, and they will be better and better. So having quick view on the domain and good tools for modeling, we can now focus on better model validation, on all these techniques, exploratory model analysis techniques that help us to understand what the model has learned from the data. And this will create this feedback loop that maybe out of things that we have learned from a model, then we can increase our understanding of the domain. So the feedback loop will be possible because these steps will be easy and we'll have more time on this. Looking at problems like fairness, ethics, things like that. So I hope that the topic of model exploration is interesting to you. If so, I encourage you to test our direct package, which is based on exploratory model analysis methodology. So you can find our detailed description of these methods in the book, which is available online. I think that R is the perfect language to talk with models, and we have many excellent tools in R to talk with models. One of them is IML package developed by Christopher Molnar. Other is Flashlight package developed by Michael Meyer. And we have also packages like PDP, Aleplot, VIP, and many other packages. So it's really that we are fully equipped with good tools to do this exploration, in-depth exploration of a model. So that's all from my side. I hope that you are more convinced that by talking with models, you can learn more about the model and about the domain. And there is still a lot to do in this area. So we need better tools to go deeper in the model exploration. I would like to thank my colleagues that are working on these tools. You see names that are behind excellent packages for different methods that help us to explore model in a model agnostic fashion or model specific fashion. So that's all from my side. I will be happy to take questions if there are any. And in the meantime, I will try to open the YouTube video. So maybe during the questions, I can again switch to the presentation and show you the video that was not working as expected.
Great. Thank you so much for the talk. I have a couple of questions here, and if you want to ask any question and you're on YouTube right now, please go to the description box and click on the Slido link. You'll be able to type in your question and we'll be able to catch it on the side. So the first question we have is, how do we deal with errors when we bring together models that have been made in different libraries?
How do we deal with errors?
When we bring together models that have been made with different libraries.
Okay. Sorry for this technical errors, like errors in these libraries or errors in model predictions?
So I think this is errors in model predictions, because
Okay.
every model comes with its own errors from different libraries. When we bring it together now, how do we move forward?
Yeah. I think that this is an excellent question, because for debugging, I would say that for debugging, if you have a model with very large residual for a single observation, so the error is kind of large, so a very natural approach would be to see what would be the model prediction provided by other model. So maybe for this single model, this observation is kind of out of domain, is well approximated. So the Rashomon effect is, okay, let's see other models. And let's compare these predictions given by different models. And then, like, we are not forced to make our decisions based on a single model. It's very common practice right now that we need to choose a single model, but why? We are not forced to do so. We have some collection of models with equally good that will kind of suggest their predictions, and then the human expert will choose the prediction he or she likes. This might be an answer that models might be different, and actually predictions might be different for different models, and this might be actually a positive effect, because then we can compare predictions from different models.
Great. So
can I just,
question, okay.
Sorry, can I just quickly, Czemek, if you want to send me the link to the video, I can try if I can share it.
It's working right now. So if I can just spend 1 minute to show you the video. Yeah, sorry, it was not working properly previously, but this is the Model Studio dashboard created with a single line based on a trained model. In this case, it's a GBM model for FIFA. So you can compose your view on a model by selecting different methods. Like on the left, you have the Shapley values or breakdown values. On the right, you have Steris Paribus profiles. And then you can compare, okay, the age has negative effect, why? On the bottom, you have the distribution of this feature. So you will see that the age 30 is far higher than the median age or average age. So the interactivity gives you this ability to explore the model in detail. And you can choose different points, like here you have Messi. Messi has 32 years. So for him, the age also has negative effect. And you can choose Ronaldo, which is a well-known player, but Ronaldo is 34 years old. So for him, the model prediction is that the value of Ronaldo is even 4 million lower because of age. And for Neymar, it's not the case because Neymar is relatively young. So sorry for these technical problems, but having interactivity, you can have this very quick feedback loop. You can go through all these different perspectives very quickly. So I'm ready to take another question.
Lorna, you muted. And Cemik, can you stop sharing the screen so we can see you both? Thank you.
Okay, great. So the other question is, do you think it is still timely for us to think in two cultures? That is to say, to think in terms of statistics versus machine learning. Isn't it time for us to talk about models and how they have their own different strengths?
Yeah. So I like the sentence, make models, not wars. So I totally agree that we should not look for differences. We should look for differences that two cultures or different languages and so on. I think that Riemann observed different approaches by using different problems, and these different groups of people are using even different languages, like variable versus feature. But the problem that we are going to solve is the same. Like, we'd like to understand better what is happening and have better models. So exactly, I think that we can bridge these two approaches, learning from strengths of each of these cultures. And as statisticians, we should not be kind of, we should be welcome for these very elastic, but sometimes black box models. They can be very useful. And as a machine learning or data scientist, we can also be more open for this detailed diagnostic that is forced by statisticians. So yep, I think that we can learn from both cultures and they can be bridged, and we should bridge them.
Oh, great. So another question is asking you to briefly discuss how exploratory comparison of model calibration works.
Exploratory comparison for
I think this goes back to the video you've showed us,
okay.
How the studio calibrates different model parameters on different sides.
Okay.
And yeah, I think that is sort of the process. Yeah. Sorry about the background noise. So, I think that is sort of the process that they wanted to clearly see, because we had not seen that during your presentation.
Yeah. So if I understand the question correctly, I would say that once the model is trained on the data, it's, for me at least, is a p-dimensional function. So we don't have a problem with parameters because we have the function trained, and this might be a black box. So maybe inside of a black box is a human, not a machine learning algorithm, or maybe there is an ensemble of models. So in this explanatory model analysis, once we create an adapter which knows how to query model predictions, then we are kind of, we have this level of abstraction. And having the level of abstraction, then we can operate the model in a model agnostic fashion. So it doesn't matter which library was used to create the model, because we can explore the model in a unified fashion. So hope this helps, hope this answers the question.
Yeah. So the other question is about the DALEX package. Is the DALEX package using Shiny for creating an interactive model studio? Have you thought about Shiny?
So we have tried Shiny, and we have even experimental package called Shimex, Shiny Explanations, which is pretty cool because then you can really connect with your Shiny server all the time. But actually here we use Model Studio to generate standalone HTML web page, because then the web page can be easily shared with other people without having Shiny in background. So sometimes you like to store your models for longer period of time. And if you like to explore your models after a year or a few years, then it's good to have something that it's kind of standalone. And with Shiny, you need to take care about same version of packages that were installed when the Shiny was created. So yeah, you have larger flexibility with Shiny for sure, but having this standalone web page make it much easier to share your results with other persons. So,
yeah, so another question about Daleks still is, how does Daleks differ from all these other modeling packages?
okay, I think that in terms of methods, there is huge overlap between these packages. Like I've told you about Flashlight, about IML, and about Dalek. I guess that sometimes there are differences because of particular applications. So for example, for Flashlight, Michel asked me, can I add weights to Dalek to support weighted regression? And at that time, it wasn't so easy for me. So it was easier for Michel to create his own package that is kind of focused on weights. And I think that for IML, there is a larger support for interactions, for two-dimensional interactions. So I guess that the strength of R is in the variety. So we have different tools and they were created for different purposes. So yep, let's use many of them. The important part is to dig deeper, see how the model is behaving, and it's good that we have so many different options.
Great. And Daleks brings together all those options into one place.
So the idea was to create this pyramid, which would be kind of uniform process of procedure how to deal with models. So for me, it was maybe more important to provide an idea how we can explore model, what would be the process for model exploration, rather than on particular methods. Again, I'm a software engineer by training, and for software engineers, the huge part of training is the development process. That to create a model, it's not a random try and error approach. It's a process which has phases, iterations, there is a team of people. So I guess that this pyramid is a kind of way to put these pieces together in a way that will be easier to understand. And you should think about new methods, and these methods can be put in the process, can fit in the process.
Great. So 2 more questions. One about Daleks. Are you using Daleks in your teaching? And if so, how are you using it?
Okay, so I have classes related to interpretable machine learning. So in these classes, I use Dalek as a tool for methods like Lime, Shapley values, all other methods. And I'm using Dalek because it gives you very uniform interface to these methods. So sometimes people are confused because there are so many different names, like this name, other names. So I guess that one advantage of Dalek is that all these names are kind of uniform. It's always prediction or model underscore, and there is a profile part or something else. So it's easier to understand how we are going to explore the model. Another way how I'm using Dalek is to show consequences of the internal model structure, because I guess for many people, they learn about boosting or they learn about bugging, how these methods are working, but it's not easy to get this intuition that with random forest you have regularization, and on boundaries you will be kind of, because of the bugging, you will be the bias will be larger, but the variance will be smaller. And for boosting is vice versa. The variance will be larger, but the bias will be smaller. So by showing these profiles, like in terms of COVID, by showing that here you have very large variation, but very low bias, then I think it's easier to understand what is happening with these algorithms, because we have large number of algorithms, machine learning algorithms, but sometimes I think that it's easier to build intuition based on these visualizations. So once you can plot these marginal profiles, partial dependence profiles, you can have better intuition how these models are working.
Great. So another question on Dalek is, I've seen you also work with live and breakdown packages. Does Dalek substitute these packages?
Yes, so I really like this slide by John Chambers about interfaces, because for me, Dalek is just interface to other tools. And in this case, it calls breakdown library or ingredients library or other libraries like PDP to calculate something and to wrap all these other algorithms in kind of unified interface. So I don't think about Dalek as a kind of a new method. It's more about this interface. But we really need this interface to have this quick feedback loop, not to learn a new name of a function, a new name of a procedure, but to put this procedure in context, like in periodic table. We can learn about new elements, but we know where they should be fitted in the periodic table. So yeah, same with Dalek.
Okay, so the last question is a small clarification. Are partial dependence plots and ceteris paribus plots the same thing?
They are closely linked. Ceteris paribus plots is for single observation. So it's like keeping everything else constant, how the model response would change if the age is different. And partial dependency profiles are average across all or large number of observations. So they are working very similar fashion, but one is for instance level explanation, local explanation, and second is for global explanation, for model explanation. So in this pyramid, they're on the same level because they are showing a profile, but one of them is focused on the instance in the observation, and second is focused on the whole data set of the whole distribution.
Great. Thank you so much, Shamik.
Thank you. Thank you very much.
Thank you for the talk.
Bye.
Someone reminded me that I didn't introduce myself. I've been your host, Lorna Maria. I'm a data analyst working out here in Central Africa with UNICEF. So I'm going to invite Chris to take over the handover now.
Awesome, thank you. I want to thank everyone who's joined and watched our sorry about that. Make sure we have the right slides up. Nope. Heidi, can you share the slides?
Sure. I can see your slides though.
Oh, you can?
Yeah.
It wouldn't be, there has to be
I
at least one technical glitch during the conference, right?
I can. Let me do that right now.
On my end, it's not showing the slides. Thanks for your patience, everybody. Sorry about that. My name is Chris Brenner. I'm one of the three and apparently very technically challenged co-leads for USAR 2020. I want to thank everyone who joined us for our live keynotes. I also want to thank USAR sponsors. USAR is not possible without sponsorship support, and in particular, our studio for providing us the very generous support that made our keynotes and tutorials possible. I also want to thank a number of other groups that have made USAR 2020 possible. First, our three institutions that provided support on the ground for the in-person conferences, as well as the virtual conference. And so St. Louis University and Washington University in St. Louis were major supporters of the St. Louis in-person conference. And the University of Munich was a supporter of both the satellite as well as the virtual conference. So thank you to those institutions, as well as the local organizing teams who worked incredibly hard to make the in-person conference and then the virtual conference happen. In addition to those groups, I want to thank a couple more, the R Foundation and R Forwards, who are longtime supporters of USAR. as well as 3 groups that have helped us make the virtual tutorials possible. So Our Ladies, the Mirror community, and then Africa R. And finally, our captioning, which is provided by White Coat Captioning. We want to thank them for their support as well. Now I'll turn it over to Janine, our other co-lead from USAR 2020 in St. Louis, who will talk a bit about tutorials.
Great, thanks, Chris. I'm Janine Harris from the St. Louis team, and I just wanted to give everyone a quick reminder that we have 15 tutorials coming up starting on July 14th. And they have 25 amazing instructors and will be hosted by Our Ladies, Africa R, and My R groups from all over the world. The registration links for these tutorials will be posted on our website. The URL is there in the bottom left corner of the slide, or you can just go to our website and look for tutorials. And I just wanted to thank you all for being a part of USAR 2020. I know I learned a lot from the speakers in the videos. I hope that you learned something new, or maybe became aware of someone new and are coming away from this virtual conference inspired about R and about the R community. And I'll turn it over to Heidi, who is the conference co-lead in Munich.
Thank you, Janine. Thank you, Chris. I quickly need to go to my speaker notes and so that I remember what I wanted to say. Okay, can you see this all right? Okay, now you've already noticed that this farewell is not really a farewell. There's still much to happen at this year's USAR. The only thing that we're finishing today really are the keynotes. But you can keep going for much, much longer. As you just heard, of course, we have many tutorials that will happen in the upcoming weeks. But we even have more than that. We still have plenty of content for you on YouTube. All the recorded contributed talks will continue to be available on YouTube, and you can also find the supplementary materials for those contributed talks on our website. Also, the live keynotes and breakout sessions were recorded and are available for you to watch on YouTube. Finally, there's one more exciting breakout session, which will happen next Friday, July 17th. The breakout session on supporting diversity in the R community, which we're really excited about. Don't miss it. We are incredibly happy with how this conference went in the end. Of course, we would have loved for this to be an in-person event and meet you all, but I think given the circumstances, we've really made the best of it. And with an online conference, we were able to decrease some of the barriers that regular conferences have. For example, we were able to caption all the events, and we were able to have a conference without registration and without fees. So anyone really with an internet connection was able to be part of USAR 2020. And that to me is a great victory. And with this, I would like to hand over to Heather Turner, who has been an amazing support for this conference.
Thank you very much. I'm Heather Turner. I'm on the R Foundation Conference Committee, and in that position, I would very much like to thank the organising teams in St. Louis and Munich for coping with very difficult circumstances and reinventing the conference at fairly short notice, and for all the other people that chipped in to pull this off at the last minute. I'd also like to thank our sponsors once more because they have enabled us to run this event and make everything available for free, which is really amazing, and so I thank them for their support. But what I'm here to talk about is the USAR 2020 survey. As you've just heard, there is lots more of exciting stuff for you to watch or attend. And once you've watched all or attended all that you expect to during July, we'd like you at that point to fill in our survey, which you can find at bit.ly/USAR 2020 survey. That's bit.ly/USAR 2020 survey. The survey is run by Forwards, which is the R Foundation Task Force for Women and Underrepresented Groups. And the survey will ask you a bit about yourself, your involvement in UseR, and what you think of it. So that's why we want you to wait a bit until you've caught up as much as you're able on all the recorded content, and perhaps attend a tutorial before answering the survey so that you can give us your full opinion. It's interesting to know that Heidi was looking at the stats for YouTube, and according to them, we're less than 20% female in terms of viewers, which would be a bit disappointing if that's true. So we'd like to get some hard data. So we're very interested to see how this virtual event compares to previous UseRs. So please do take 5 minutes to fill in the survey. Thank you very much. Now I'd like to hand over to Matt Bannett, who's got an announcement to make.
All right. Hello world. So this is the hello world of UseR 2021. Thanks Jenin, Heidi, and Chris, and the whole UseR 2020 team, not only for the opportunity to carry on tradition and announce UseR 2021 in here, but also for your extra mile, the extra mile that you went going virtual on the fly this year. You've also sort of paved our way. UseR 2021 will be a global virtual conference. And we are excited about this chance to host a truly global, truly inclusive in a sense that anyone can attend and participate, and community-driven conference. We would like to thank the R Foundation and the conference committee in particular for their ongoing support and the great help in the decision process. In the next step, we will now work with the RFCC to extend our local team here in Switzerland to become a global team. And if you want to follow the process, follow us on Twitter, which is UseR 2021 Global, or visit user2021.r-project.org. As a community, let's really try to embrace the chance to form a truly innovative conference, benefit from the pioneering work and the fact that we can at least somewhat plan for 2021. And my wish to the community is let's try to stay involved, and let's involve really everybody who wants to be involved with UseR 2021. Yeah, that's it for us. Thanks for your time and listening, and yeah, stay tuned for 2021.
Okay, thank you everyone, and bye-bye from our side.
Thank you, everybody.
Thanks, everyone. So long from St. Louis.